Hi scholars, welcome to the presentation on multiple baseline and multiple probe designs. Our two objectives in this session are to describe components of multiple baseline designs and describe components of multiple probe designs. The multiple baseline design requires continuous repeated measurement in the baseline phase. We use this design when behaviors are freely emitted or not on a schedule. This design can be impractical for a couple reasons. One, there's repeated continuous testing, and so students, participants, subjects can become bored and fatigued with that repeated testing. Also, they might search for the answers after they complete the test. The distinguishing feature between the multiple probe and multiple baseline design relate to what happens prior to the introduction of the intervention. In the multiple probe, we use intermittent repeated measures in the baseline only. In the multiple baseline, we use continuous repeated measures in the baseline. Both designs require a minimum of 3 consecutive and stable data points prior to the introduction of the intervention, but 5 data points are ideal. Both designs require that after the intervention starts, data are continuously collected. We show replication using multiple baseline or multiple probe in one of 3 ways. We can use replication across behaviors, across participants, or across conditions. Multiple baseline or multiple probe across behaviors could be something like word sets or math facts. In this case, we want functionally independent behaviors. So different words in those sets or different facts in those sets, but we want them to be similar, perhaps of equivalent difficulty, same number of syllables, same level of challenge with the encoding or decoding of those words, to avoid inconsistent effects in the intervention. Multiple baseline or multiple probe across participants can happen at the level of an individual or group. Multiple baseline and multiple probe across conditions might be something like across settings or materials or other arrangements. It's sometimes hard to establish independence across settings, materials, arrangements, so we don't see many studies that use multiple baseline or multiple probe across conditions. The main guidelines for this design are that the behavior that we're intervening on should have functional independence across behaviors, participant settings. We should have functional similarity. We need to introduce the intervention when we've got stability in baseline or the trend is moving in a contratherapeutic direction for at least 3 data points. Again, 5 is optimum. The previous tier's intervention data need to meet criteria either by establishing ahead of time a set time frame, like 7 sessions in intervention before we start with the next participant, or they should achieve some specified criterion like 90% correct for 2 sessions. We use our repeated measurement in the multiple baseline across both phases, A and B, and in the multiple probe, we use intermittent measurement in A and continuous in B. At least 3 tiers, whether that's 3 tiers of participants, 3 tiers of behaviors, 3 tiers of settings, to have replication in this design. So in the following slides, I'll display graphs. We're going to look at what is the design, is there intra-subject, inter-subject, or both, and is there a functional relation? Here's our first graph. We've got an A-B design. This is data for just one participant. We'll call it intra-subject replication. I see a low level in baseline, a shift to a higher level at intervention, a return to a low level at baseline, and a return to a high level at intervention. 3 demonstrations of effect, 1, 2, 3. We can call this a functional relation. Second graph here, what I'm seeing are some functionally independent yet similar behaviors, most likely for participant A, B, and C. I've got 3 participants, and I've got this staggered introduction of an independent variable continuous measurement in baseline. This is a multiple baseline across participants' design. There is inter-subject replication. Here's participant A, replicate participant B, replicate participant C. I don't see any intra-subject replication because what we essentially have here is an AB. If we would have returned to a baseline, we might see ABA. Depends on what this behavior here is, whether or not that's feasible. So what I'm looking for is a functional relation. That means I've got a level shift from baseline to intervention. I see that happening. I see the accelerating trend in intervention. Is this replicated across participants now? So we have 3 demonstrations of effect at 3 points in time. When participant A moves to intervention, data, looking vertically to analyze here, are stable and low for participant B and C. So we can call this replication 1, demonstration 1. Now replication 2 here, I'm looking when participant B moves into intervention, we've got a little bit of a delayed effect. Participant C is staying low. We can call that a demonstration and this a demonstration, but because these are delayed effects, the level change is delayed. It's not this immediate abrupt change in level. This functional relation is a little bit weak. Final graph here. What I'm looking at are number of sessions on the x-axis, and I see sets. So these are behaviors for one participant. The measurement is intermittent. We've got continuous probing, intervention, continuous probing. But on the other 2 sets or behaviors, we've got continuous probing, this intermittent space of no probing. So what we're going to call this design is the multiple probe across behaviors. This is for a single participant, so we have intra-subject replication. How do I check for a functional relation here? Well, I've got stability at a low level in baseline across all 3 sets. I start intervening and I see a pretty significant change in trend and level. However, in the second probe, data are low for the word sets that we haven't intervened on yet. Data remain high for the word set that we did intervene on. Now I'm going to intervene at word set 2, and I'm looking in probe 3 to see that yes, they've maintained it. Probe 3, yes, they've maintained for word set 1, but for word set 3, that's still low and stable. After introducing this intervention to word set 3, I see this shift in accelerating trend here. I see the student maintains their accuracy. For word set 2 in probe 4, they've maintained that. In word set 1, they've maintained that. So I've got this kind of staggered introduction of the intervention, intermittent probing in baseline, and a demonstration of effect for set 1, replication for set 2, replication for set 3. There is a functional relation in this design. With our multiple baseline and our multiple probe, we have to do this vertical analysis where we're looking to see a shift for baseline to intervention on the first tier, but we want to make sure that once we move into intervention, the data points for the tiers on which we've not yet intervened remain stable. So I'm looking for a shift in the pattern from baseline to intervention. At that point that the first tier is in intervention and the other tiers are still in baseline, what I'm looking for is a stable pattern or a contratherapeutic pattern. So I see here when this individual A moves into baseline, there's not a huge amount of difference in terms of level. Over time, the trend accelerates, but participant B here stays fairly stable. something's happening with individual C where we're seeing a deceleration prior to the introduction of the intervention. There's some threat at work here because the data are decelerating when it doesn't seem likely that they should be because they haven't yet received the intervention. The same threat happens for individual D. So maybe there's some intervention at work where participants A and B at some other point in the day started sharing or using that intervention technique, and it shifted the behaviors of individuals C and D. So this vertical analysis is important for us to identify and detect these kind of threats to our design. Internal validity is inherent in the multiple baseline, multiple probe across participant settings behaviors. Because of that stagger and time lagged effect, we can check for threats like history maturation testing. Our experimental control is visible when we see change only upon introduction of that independent variable. It should be immediate and it should be abrupt. This can then be replicated across the tiers. We were looking for a minimum of 3 demonstrations of effect at 3 points in time. External validity is possible with this design because of the inter-subject replication. When you use multiple baseline across participants, multiple probe across participants, you can do something like multiple probe across behaviors replicated across participants. Threats to internal validity remain. We want to check for covariation across tiers. If we have fewer than 3 replications of effect, we can look to see what might be at work. Is there some sort of inconsistency at play that we can adjust for? Testing is a potential threat because of the repeated measures, right? There could be facilitative or inhibitive effects of testing. Our strategy is to control for this might be use the probe instead of the baseline. That gives you some intermittent collection. Decrease procedural contrast between conditions, shorten session length, or adjust response opportunities. We could reinforce during some conditions, like interspersing knowns with unknowns, reinforcing alternative behavior between trials. The advantages of this design really are that we don't have to withdraw the intervention. There's ethical appeal because we can use this design with reversible behaviors, so we can teach academic and functional skills. Limitations are that we have to identify these 3 functionally independent behaviors if we're going to use multiple baseline or multiple probe across behaviors. We have to withhold the intervention across students. Now later, if you learn about randomization, you can set a window and then you'd be able to at least inform caregivers or guardians of when you're likely to intervene within which window. But otherwise, we're waiting for stability in baseline, and that can go on and on and on, and that can be a major disadvantage for this design. So what do you think? Here's a kind of critique in the field. We'll investigate more of this in the critical issues module, but if we were to do something like a delayed multiple baseline or multiple probe or a non-concurrent multiple baseline or multiple probe, people critique this as basically just a stacked set of A-B design graphs that doesn't control for history or maturation. If we did this first student in, say, the fall semester, this next student in the spring semester, and this next student in the summer semester, these are not concurrent. We might be measuring the same behavior, using the same intervention, but they're not happening within the same time frame. So they're non-concurrent, essentially A-B designs. Is this less valid? Is this not a robust design? Some ways that you might want to push back on that would be, what is concurrent, really? So if I do a design and I'm intervening with my very first reading group of the day in one room, and then in another room a interventionist is also intervening with the second group or tier, what if I start this lesson in my first group at like 9 o'clock a.m. and the other teacher starts at 9:01 a.m.? Is that non-concurrent? What is the degree required for this to actually be valid? I'm kind of interested to know what your thoughts are on the validity of non-concurrent multiple baseline designs. And again, we'll read more about that later in the course.